Hello everyone, so today we're going to go ahead and discuss the Desmos activity. So this is something we did in class. So I'm going to go ahead and fast forward right to where the activity started. Um, so once you logged in, once I give you guys the link in the chat, you went ahead and saw that there was this little matching sort activity, and we're going to go ahead and find the parent functions. So right here, have this little graph right here that looks like a linear, so I know that that function associated to it will be this right here, this x. This one right here, e to the x, that's a little bit more complicated, but hopefully you see it's an exponential. So when you think about something that is exponential, it looks something like this, right? It's something that started off really small and then exponentially grew bigger. So it will be this graph right here. Oops. Okay. Alrighty, let's go with this one, absolute value of x, absolute value of x. So it looks almost like a parabola, but they actually both sides go positive in the y at a constant rate, right? Your x matches your y, so it looks like so. Okay, so far so good. This one right here looks almost like an exponential, right? Exponential is right here, but it's not quite the exponential. And you can see that it is the inverse of an exponential, and hopefully you remember parent functions, that is a logarithmic function, the inverse of an exponential. Okay, so now I got this one. I got these right here left over. Okay, let's go ahead and do x squared. So x squared, our parabola, our quadratic, our happy face parabola looks like this one. So here's my parabola. This right here, the square root of x is this one right here. Whoops. Is these two. Okay. Alrighty. I know these look a little small, so if you actually click on them, they give you a bigger picture. So like this one right here, we can go ahead and see this is 1 over x. And this, all of this, guys, I know it because these are the parent functions, that little pamphlet that I gave you guys. If not, I'm going to go ahead and show you guys the parent function does, and that does help a lot of students out. And this right here, I like to call it the ballerina because, like, you know, one hand up, one hand down. So the left hand goes to negative infinity and the right hand goes up to positive infinity. Looks like a ballerina for most students. So this was what we had for the introduction. So quick reminder of the parent functions. Okay. Alrighty. So let's go ahead and continue. Okay. The next part of the activity asks you that we're going to go ahead and play with the slider K. So it's this right here, right? In tab number 2, and we're going to go ahead and see what it does to the function. So oops, so this right here, we have the original function is this f of x plus k. We don't know what f of x is, even though we can probably tell it looks like a quadratic. So I'm going to go ahead and play with it and see what I observe. So I'm going to the positive, I'm going to the right. So according to this, going to my positive 10, and it looks like it's going out of my screen. So it looks like it's going up, right? The higher I go. Okay, let's go ahead and look backwards. So I'm decreasing. So now I'm going to the negatives, and I can see that my original function was that dotted black line, and I'm noticing some shifts here, right? Vertical shifts, right? So as I go up, it goes positive, and as I'm going down, it is going negative, right? So it's asking us, what can we conclude given the transformation that happened with k is positive? So we just noticed that when k is positive, right? When k is a positive number, it goes up. So when k is positive, it's a vertical shift up. What can we conclude when it's negative? Well, it's when k is negative, it is a vertical shift down. And hopefully you saw that if you go ahead and add a positive number, your entire shape, everything, every single point goes up. And if you add a negative k, every point goes down. Okay, so that wasn't that bad. Let's go ahead and look at this one. Similar idea. What do you do when your your h is positive or negative? When what happens? Well, the first thing that I want to go ahead and notice is that my h right here, the value that they're asking me, is inside these parentheses. So let's go ahead and make some positive values. Let's see what happens when it is positive. So keep in mind that that dotted x line is the original function, And as I'm going positive, it's going to the left, okay? So as I'm going negative, it's going to the right. So this is something very important that I need you to know. You hopefully remember from Algebra 2. But whenever K is positive, it does the opposite of what you think. So if it is positive, it goes left. And if it is negative, it goes right. So let's go ahead and write that. So what happens when what happens when it's positive? And I'm sorry, H is positive. It is a horizontal shift to the, if it's positive, it goes the opposite of what I'm thinking, so it goes left. What happens when H is negative? So when H is negative, it goes right. Okay, so this, hopefully you saw that every point shifted horizontally. Okay, let's go ahead and try the next one. And this right here was a game where I wanted you guys to catch this little stars, right? So they give us a quadratic, which is that dotted line, right? The x squared. And they want us to go ahead and do what we can. I don't know why this keeps popping up. Do what we can to get this parabola to catch all the little stars, right? And there is a launch button right here. Let me go ahead and hide this. There is a launch button, so that launch button lets me drop the ball. So as we can see, I didn't move the parabola, so it didn't catch. It only caught one. So let me go ahead and try that. Okay, so I'm gonna go ahead and see that I should have something x squared. Okay. Now I wanted to catch those balls right here. I'm sorry, those stars. So I should move it to the right. So according to what I just learned, my H has to be negative. So minus, let's take a guess at it. Let's shift it to almost, it shifted 3. Okay. So now I'm roughly where they should be. So the minus 3 shifted it 3 units to the right. Looks good. Let me go ahead and try it. Okay, and it looks like I got it. I know when you guys were doing this activity, a lot of students went ahead and did a +1, and that also worked. The idea is to catch all the stars, whether it is passing directly through them or roughly on them. So that one and the other equation both work. Okay, let's try the next one. Okay, the next one says pick an equation that represents the given description. So they want us to have a cubic function that has 2 units to the left, right? And 3 units, I'm sorry, 5 units down, and forgive that typo right there. Okay, so 2 units left, so 2 units in the left direction. So remember, that's our horizontal shift. Horizontal is the opposite of what we think, so it should be a plus, right? So now between these two. Okay, and then 5 units down, so that's my K is negative, so it should be this one, and I got a little correct symbol right here, so way to go, us. Okay, this one looks a little intimidating, but let's go ahead and see what it says. There is a change in value A in the line 2 that's talking about vertical dilations. Okay, so dilations, hopefully you remember that from a geometry, that is a compression or a stretch. Okay, so instructions are the same. Use the slider, okay, to match the black graph into the other graphs. Okay, so I'm gonna go ahead and use my slider. So as I'm going positive, bigger than 1, I match that purple one. Okay, so the closer I get to a larger positive number, it looks like it's getting thinner on the y-axis, right? Another way to say that is that it's getting vertically stretched, right? Similarly, we can see that if I go between 0 and 1, it's getting stretched horizontally, or it's getting pushed towards my x-axis, okay? And then I'm seeing the negatives do the same thing, but it just reflects it over the x-axis. Okay, so let's go ahead and write that down. So explain what happens between, explain what changes happen between 0 and 1. So we just saw that between 0, where's my 0? Between my 0 and 1, it's a vertical compression. Vertical compression, okay? Summarize the values that change the function. So the next one says, how does this change the function? Well, as we just said it, if it's A is bigger than 1, then it's a vertical stretch, okay? And if it is less than 1, it is a reflection over the x-axis, okay? Alrighty, so let's go ahead and do a little quick check for understanding. So I have the function 2x squared, negative x squared, and 1/2 x squared. So I'm going to go for the easier one here that says negative x squared because that's just a parent function that is reflected about the x-axis. So these right here, go ahead and match. Okay, here is the tougher ones. But I need you to remember that when that value, the a, the number in front of the x squared, is bigger than 1, it's a vertical stretch, meaning it gets closer and closer to the y-axis. Okay, therefore, when it is between 0 and 1, I got that it is stretching it horizontally or compressing it vertically, meaning it's making it closer to the x-axis. Okay, this one is a good one also well. So we're going to go ahead and see the transformations right here. And we're going to go ahead and see what transformations occurred so I can get this one. So for me, that looks like quadratic. So I'm going to start off by putting my x squared. Okay, so now I got that black function. It appears that it went 1 unit, and I could believe I can draw on here. 1 unit, 2 units, 3 units to the right. So let me go ahead and put a +3. Wait, sorry, not a +3. A -3, correct? Because it went 3 units to the right, so I need to do the opposite. And it went 2 units up, so +2. Okay, so now I need to go ahead and see that the blue function is a little thinner than mine. So that probably means it went through a vertical stretch. So I'm going to go ahead and put a number here bigger than 1. And I can see that 2 matches that perfectly. And the reason was that, and I'm going to go ahead and show it again. I have x by itself. But remember, if I was to put a 2, it makes it vertically compressed. If I was to put a 10, it gets vertically stretched. Okay. Alrighty, let's go to my next one. Horizontal dilations. So same thing, but now horizontally. I'm gonna go ahead and work with this one. And this is my change in B. So the B is inside those, the parentheses. Okay, so we're gonna do the exact same thing. And the question is asking, what do you notice when we match the black function to the green function? And it appears that it's already on there. Sorry about that. It should be right here. Okay, so I have my original function. Let's call it 1. Whoops. Okay, 1. So as I match it to my green function, okay, notice what it's doing as the numbers get bigger. So I'm horizontally compressing. Okay, so I'm going to go ahead and compress it like so. What happens when we match right here, when we match the functions to the blue functions? So that's happening when it is between 0 and 1. So between 0 and 1, you can see that I'm horizontally compressing it. And we can see that the last one is just a reflection about the y-axis. So very, very different. So when B is negative, it flips it across the y-axis. Okay, let's go to the next one. Okay, let's go ahead and do this one right here. And what I want you to know is that there is points right here that we can go ahead and refer to. Okay, so I can see my point is right here on my original function, 1, 1, and that this one is now 4, 1. So we're gonna go ahead and see that that got horizontally stretched, what you would say is a factor of 4. So let's identify our parent function. Looks like that ballerina, right? So it's gonna be x cubed. Okay, now I need to go ahead and see that it has been compressed. I'm sorry, stretched horizontally. So I'm gonna go ahead and put my little parentheses right here because I need to put a value here. So let's go ahead and guess and check. If I put a 2, it's making it horizontally compressed, right? Because it's bigger than 1. If I put 4, it makes it even more, horizontally compressed. So it must be a fraction, right? So 1/2 would give me this. So it gave me my double, right? It always does the opposite of what you think. So I'm gonna go ahead and see that it must be a 4. And I can see right there, it lands perfectly on them. So it was horizontally stretched by a factor of 4. And that was my solution. Okay. Last but not least, I gave you guys an exit ticket, and I gave you all the transformations, the ones that you saw before, your A, your B, your H, and your K. And you were supposed to match this function right here with the other function there by moving these any certain way that you want it. So let's go ahead and play with this. Let me go ahead and move it over here. And I can see that I need to match it to this dotted blue line. Okay. So the first thing that I want to do is I'm going to go ahead and see how I can change my A. Well, that looks very, very tiny, but it did help me see that I can reflect this certain way, right? So I can match up perfectly. So I got a negative A. The next part is I want to go ahead and match it. So this B went ahead and helped me out to make it horizontally compressed, right? Because my B was bigger than 1. And then my H is going to help me move it to the right. So in order to move it to the right, I need to go left. Okay. And then my K is helping me move it vertically up or vertically down. So I'm going to go ahead and move it down. It looks like I got it, ladies and gentlemen. So these are the transformations that they wanted. Okay, so I'm going to go ahead and say them for you. What happens when with A? Well, A, according to this, is my amplitude, pretty much my vertical stretches. It is a vertical compression or stretch. Okay. My role for B is similar to A, but it's horizontal. Compression or stretch, right? My role for H is horizontal shifts, left or right. My K is vertical shift, up or down. And they want the exact equation, and I believe these are these values here. I'm going to go ahead and move this all the way up so I can go ahead and get a nice number. And it appears that my function that they wanted, I'm going to go ahead and say h of x, so I can make a different color. It was -1, and then it was the function, which it appears to be my cubic function. Or in this case, f. Let's see if that still lets me do it. B was 2. My variable was x. And then my h was a -3. And my k was a -3. Ta-da. And now I got it to be right there. Awesome. So this was the entire lesson that we did today, and hopefully you guys were able to see this first before we jump into all the algebra. But this is a nice way to to play around with math, since it does look a little intimidating. Awesome. Thank you. As always, it's a pleasure. Until next time.